This is a very important video for all those who are learning calculus. We'll take up around 20 examples based on optimization and rate of change. I will also discuss with you how you can actually watch my videos on YouTube and learn. You can also contact me on the email address given here and enjoy the journey of success. Let us now have a lesson with Akshat and understand how do we prepare for the test. Hi Akshat, how are you doing?
Hi, sir. I'm good. How are you?
Very good, very good. So today, what do you want to do in calculus?
Sir, today I was hoping we can discuss some optimization problems in relation to rates of change.
Right. So when is your test on this?
Sir, I have a test on this for this coming Friday.
Coming Friday. Great. So what I will do here is that, I've got hundreds of examples on this topic of optimization. So I'll go through some of my videos and share with you some very important questions, right? So we
Yeah.
will be sharing at least 10, 15 questions in this session. You should get ready for your test once you understand all those things. But remember, you have to solve those questions after this class yourself,
Yeah.
so that you really gain the confidence and maintain your position to be right on the top. Okay.
Yes, sir.
So let me just share with you the YouTube channel. So can you see my screen, please?
Yes, sir. I can see.
Great. So can you please read what is given in this particular video? I'll provide you with the links. Yes.
Yes, sir. It's a calculus application test review,
Correct.
where we deal with optimization and rate of change applications, including marginal cost, optimum size of container, economical construction of road, closest boat distance, and position displacement and acceleration.
Correct. So over the past 5 years, I've noticed that in this particular unit, which is basically rate of change, you have a couple of chapters. One of them is higher order derivatives, where you're discussing velocity, displacement, velocity, and acceleration, to put them in order, right?
Yeah.
Velocity is the first derivative of displacement, and acceleration is the derivative of velocity and the second derivative of displacement. So that is how it gets to higher order. So position, displacement, acceleration, which is the last topic, is about that particular chapter. And then we have closest boat distance. Extremely important question.
Yeah.
Closest boat distance means what? That means we are looking at a tangent and a normal on the tangent. Correct? So this actually connects with the previous chapter, and closest gives it a look like an optimization. Correct?
Yeah.
The analysis of the first derivative will be involved here to find or to verify that this position is indeed the closest. A more difficult part in this particular unit, which I think many students do not lay so much emphasis on, is the financial applications of calculus.
Yeah.
So that is why the very first video which I've selected, 28 minutes, it has some very good questions based on marginal cost, optimum size of the container, and economical construction of road. All the three topics are based on financial considerations, and they are today the most important topics for your test. Do you understand that?
Yes, sir.
So we'll first define what is marginal cost. Remember one thing, wherever you have marginal involved, it could be marginal revenue, it could be marginal profit, it could be marginal cost. It is rate of change of that parameter. So rate of change of profit is marginal profit. That means, let us say marginal profit on selling 100 items.
Yeah.
Means if you sell 101st item, what profit do you get in that particular item? Do you understand that marginal?
Okay.
Marginal
Yeah.
means one additional item at that level will give you that much of cost. That is marginal cost. That much of revenue is the marginal revenue. And marginal profit is that much of profit for the next item to be sold. You get the idea.
Yes, sir. So it's basically the rate of change, right, sir?
At that point, that means
At
next
that point.
item. It's a discrete value when we talk about items, right?
Yeah.
So next 101st item. So that is how you have to see it, right? So it is
Yes,
of
sir.
course a rate of change, but it's kind of a secant. You understand?
Yeah.
Because we have discrete values involved, number of items will be one, two, three, four natural numbers, correct?
Yeah.
So keep that in mind because questions can be twisted on this concept. So if you understand the concept, you are in a position to
Yeah.
answer those questions. Very important. So do you understand the base?
Yes, sir.
Correct. I'm going to share with you this playlist. This is the most important playlist which I have. 77 videos on this topic, right? Which is a
Yeah.
very huge number. I do have at least 5 or 6 such playlists on rate of change. However, I think I've collected the best in this particular playlist. And that's why I'm sharing that with you, right? So
Yes, sir.
you understood what is marginal cost, right?
Yes, sir. I've got it.
Okay. So we'll move forward and understand what this marginal cost is. So, can you read the definition now of marginal cost, please?
Yes, sir. Marginal cost is the rate of change of cost at a given level, C prime of x. Marginal cost of producing 100 units is approximately equal to the cost of producing 101st unit.
You get the idea.
Yeah.
So, that n plus one item, how much extra do you pay for that? That gives you the marginal cost at that level. Okay. Very
Yes, sir.
important to understand this explanation is not given in any book. I'm telling you,
Yeah.
just a rate of change. A rate of change what? Right? So it's
Yeah.
very important to understand how do we relate these things, correct? So now
Yes, sir.
I'm moving to the question, but you have to watch this video very carefully, spend all the time, and get the answer. Can you please read this question?
Yes, sir. The cost in dollars to produce X liters of maple syrup is C of X equals to 75 times root of X minus 10, where X is greater than or equal to 400. What is the average cost of producing 625 liters? What is the marginal cost at 1,225 liters?
Correct. And third part, I think to be clear now. Let me just adjust a bit. Okay. Right. So what is the third part?
Yes, sir. The third part is how much production is needed to achieve a marginal cost of 50 cents per liter.
Right. So the very first, what is the average cost of producing 625 liters is very simple. Find the
Yeah.
total cost of 625 and divide by 625. You get your answer, correct? What is the
Yes, sir.
marginal cost at 1225? It means you have to take the derivative,
The derivative.
substitute the value 1225, get your answer. How much production is needed to achieve a marginal cost of 50 liters per liters? So in that case, what will you do?
You can plug in 0.5 as C prime of X, right, sir? And
Right.
evaluate for
Get
X.
the value. Correct. So that is how you're going to answer this question. It was relatively straightforward, right? So we'll now
Yeah.
move on to the next question. Internet is slightly slow today. Can you please read this question?
Yes, sir. The capacity of a cylindrical can is 1,000 centimeter cube. If the end pieces are twice as expensive per square centimeter as the wall, find the dimensions to the nearest millimeter to minimize cost.
Correct. So cost is minimized. That means you have to find the surface area. And
Yeah.
surface area is constituted of two circles on the top and bottom, and the length
Yeah.
of surface area around 2 pi r h. So you
H.
have to add 2 pi r h with pi r square, pi r square. Remember, the cost of end pieces is doubled, right? So that gives you the equation. Now, optimization questions also mean you have to write the equation yourself. Equation is not
Yeah.
broadly given to you, right? So the first question was just a starter where the equation was given to you. But as you move on, the stations, you have to write the equations, correct? So I hope in
Yes,
this
sir.
case also not very difficult. You can see surface area is 2 times pi r square plus 2 pi r h, and cost is, I'm just multiplying the first part of it, which is top and bottom of the circles, by 2, saying that cost is 2 times and that remaining 1. And then when we find the derivative of this function, we will find the minimum cost by analyzing the first derivative. You get the idea?
Yes,
As
sir.
you can see, for the calculation, we actually differentiated the cost with respect to the radius, and we found a relation. And once you get the critical number, at that time you have to test whether it is minimum or not. Minimum
Yeah.
means that it will be decreasing and then increasing, right?
Increasing.
That
Yeah.
tells you the minimum cost. You can also find minimum by finding the second derivative, but that probably you've not learned so far. So analyze the first derivative to find the minimum, and very clearly I've mentioned in this particular video how to do it, right? So go about it.
Yes, sir.
Can you please read the next question?
Yes, sir. An animal breeder wishes to create 5 adjacent rectangular pens, each with the area of 2,400 meters squared. To ensure that the pens are large enough for grazing, the minimum for either dimension must be 10 meters. Find the dimensions required for the pens to keep the amount of fencing to a minimum.
Correct. So the important thing here, it's a relatively simple question. Important thing here is when we say 5 adjacent rectangular pens, sketch it, because then you will
Yeah.
realize that the widths which we are defining W here are actually 6 of them. Do you see that? 1, 2, 3, 4, 5, 6.
Yes,
Many
sir.
times students just take 5W and L and they make a mistake, huge mistake in writing the equation itself, and therefore
Yeah.
so sketch clearly 5 pens as shown here, and then it is relatively a simple question, correct?
Yes, sir.
And then the calculations are shown to you. Once you relate area with perimeter, you have a function in terms of L, right? So
Yeah.
because area is length into width, you can write width as a function of length, and then as in the parameter, you can have one variable and answer the question. Is that clear to you?
Yes, sir. Clear.
So clearly, we have the solution right there. And that is how you're going to answer this particular question. Perfect. Let's
Yes,
move
sir.
on to the next level of questions. That was simple question, but giving you all the concepts. This is probably one of the most difficult questions on this particular topic, especially when we talk about isosceles trapezoid. So can you please read this question?
Yes, sir. A trough filled with water is 2 meters long and has a cross section in the shape of an isosceles trapezoid, 30 centimeters wide at the bottom, 60 centimeters wide at the top, and height of 50 centimeters. If the trough leaks water at the rate of 2,000 centimeter cube per minute, how fast is the water level falling when the water is 20 centimeters deep?
If the trough leaks water at the rate of 2000 centimeter cube per minute. So when you see centimeter cube per minute, it is rate of change of volume, correct?
Volume, correct. Yeah.
Immediately you write on dVdt. Leaks means decreases, means minus 2000
2,000.
centimeter cube per minute. That is what is given to you, correct?
Yes, sir.
Now what you need to figure out is how fast is the water level falling when the water is 20 centimeter deep. So dH dt, when
DT.
h is equals to 20 centimeters. That is what
Yeah.
you figure out. From the given dimensions, I made a diagram here clearly indicating the cross section of isosceles trapezoid. So this
Yes,
isosceles
sir.
trapezoid is drawn with maximum 60 on the top, 30 at the bottom. When you draw your figure like this, you will get 30, 15, and 15, right? It's an isosceles.
Yeah.
And therefore, you can now relate with similar triangles the relation between the height and the width of this particular trapezoid, because area of cross section is height times a plus b divided by 2.
By 2. Yeah.
And then length of it will give you the volume. So therefore, keeping that in mind, you have to work carefully. I like you to really do this question yourself. Then
Yes, sir.
check your solution with the given value. So clearly, we are writing what is given to us dV dt minus 2000 centimeter cube per second dS dt when h equals to 20 is what you have to figure out. And this similar triangle relates height with the horizontal distances, correct? Once
Yeah.
you do all this, you are in a position to relate uh, or get the volume in one variable, which is h, because that is
H. Yeah.
dt. Once you get that, in that case, you have to find dv dt, and you'll get dh dt as implicit differentiation part, and then you'll get your answer. Is this concept clear to you?
Yes, sir. Clear.
Okay. So with that concept, I think we'll move on to let's see the end part so that at least you have clear idea of this
Yeah.
answer. Answer is clearly written there. So once you go through it, you will understand what could be the complication of solving such a question, right?
Yeah.
It's a very difficult question. It will take at least 10 minutes for you to do it. So have patience and try to understand this question completely. Is that okay?
Yes, sir.
Now, here is another very interesting thing. Seen very few times in test papers. I would like you to read the question, please.
Yes, sir. One end of a rope is tied to a box. The other end is passed over a pulley 5 meters above the floor and tied at a level 1 meter above the floor to the back of a truck. If the rope is tied and the truck moves at 0.5 meters per second, how fast is the box rising when the truck is 3 meters from the plumb line through the pulley?
Very interesting question.
Yeah.
Now, you can see from the diagram very clearly. Here is the truck. Do you see that? And it is being tied 1 meter above the ground level, and that is the pulley. And from pulley, it is hanging down. The pulley is 5 meters above the ground, and that is the distance x which we are talking about. Correct? When
Yes, sir.
you read this question, you can see that the movement of the truck is horizontal. The movement of the box is vertical, and this is
Yeah.
what kind of a diagonal. Very difficult question to figure out and even write the equation. So I like
Yeah.
to understand the concept once you go through this so that you understand how do we relate these rate of change equations and get to the answer. You get the idea?
Yes, sir.
You can very clearly see here Pythagorean theorem helps us to connect the hypotenuse with the two legs, and that is what we have taken here. So z is this, which is the length of the rope diagonally, right? Equals to x
Yeah.
square 4 square, because this is 1 meter above, right? So we have got this
Yeah.
particular equation. X is the distance from the truck to the pulley, and there you get the equation. And then differentiating with respect to time, you could actually solve this question. You get the idea.
Yes, sir.
But again, we are not getting into any solution particularly at present, because I know that the video really explains you the whole concept. And I
Yeah.
want you to actually try these questions on your own and
Yes, sir.
then take the solution, right? Only
Yeah.
then you are going to get the confidence required to take this challenge. This is a very important test and not easy, right? Okay.
Yeah.
So that's why. Here is another question, which is about the fuel efficiency. Can you please read this question?
Yes, sir. A truck crossing the prairies at a constant speed of 110 kilometers per hour gets a gas mileage of 8 kilometers per liter. Gas costs $1.15 per liter. The truck loses about zero point 0.1 kilometers per liter in fuel efficiency for each kilometer per hour increases in speed. The driver is paid $35 per hour in wages and benefits. Fixed costs for running the truck are $15.50 per hour. If a trip of 450 kilometers is planned, what speed will minimize operating cost?
You see how many things are given in this question?
Yeah.
Probably you'll have to read this question 3 times. While
Yeah.
you read, write down what you understand so that you have the complete information and then you begin answering this question. You get the idea?
Yes, sir.
So tell me, what is given to you and what do you need to figure out?
Yes, sir. So they're asking what speed will minimize the operating cost, first of all, right?
Yes.
And we're given that the truck crosses at a constant speed of 110 kilometers per hour. And we're also given the gas price, right, sir?
Yes. And
And
mileage
how
also.
much, yeah, and mileage also, along with how much he's paid
Correct.
and the fixed cost. So I think with the fixed cost, we can create a linear equation first, right?
Yes.
And then based upon that, do we go along with the speed of the truck
Yes.
with relation to the cost of the gas?
Correct. So, a lot of parameters to connect. We'll quickly go through the type of equations involved in this particular case so that you have some idea about it. But once again, uh, you have to write very clearly what you need to figure out. How are you deriving your equations? You have to understand it, right? Spend time in
Yeah.
understanding so that if you get this kind of a question in your test, you are in a position to answer it. Otherwise, it will be very difficult, right? You get the idea?
Yes, sir.
Okay. So that is first thing. So as you can see, I'm slowly developing the concept. And while developing the concept, I'm writing each and every equation. It is not that I've got a answer from somewhere and copied it down. No, no, no. I'm working
Yeah.
with you to make you understand how each and every equation works. What is the meaning of efficiency? How this efficiency will be incorporated into the equation. You get the idea?
Yes,
And
sir.
then only you will be in a position to solve similar questions. So as you can see right from there, equation is a rational function and it's not an easy equation to work with. Correct?
Yeah.
So try to understand this particular solution. And if there is a difficulty, feel free to contact me. Is it okay? Don't
Yes, sir.
hesitate, right? And work on it. We have seen this question very few times. It is not a common question in test papers, but this is
Yeah.
actually from a previous test paper, right? I'm talking
Yeah.
about past 10 years of test papers when I'm sharing questions with you, right? So I'm skipping the one in between here, which, okay, that's interesting. So related rate with change of time, and here we have many examples. Now it just came to this particular question, which is a common rate of change question. Can you please read this question?
Yes, sir. A conical tank is of radius 3 meters and height 6 meters. Water is added to it at a rate of 5 meters cubed per minute. Find the rate of change of water level when the height is 2 meters.
So you have to relate height and radius with similar triangles. So that is simple to make an equation. So you should be in a
Yeah.
position to get this equation very easily, correct? So
Yes,
there
sir.
you see the equation and the relation on the right hand side, height over radius is 6 over 3, which is 2, which relates them both, right? So that is how you get
Yeah.
this particular question. Well, in this particular video, what you find is all these examples. Can you please read the topics?
Yes, sir. Basic concepts and formulas, displacement, velocity, and acceleration graphs, implicit differentiation, rate of change, related rate of change, and maximum and minimum optimization.
Correct. And you should know these standard formula, which relates to surface area and volume for different shapes. Is that okay?
Yes, sir.
That is the gist of it. You can actually go through this video, which is about an hour long, and definitely it covers all these topics. And there are questions like this. Another interesting question, which is a 3D example of rate of change. Can you please read this question?
Yes, sir. A railroad bridge is 20 meters above and right angles to a river. A person in a train traveling at 60 kilometers per hour passes over the center of the bridge at the same instant that a person in a motorboat traveling at 20 kilometers passes under the center of the bridge. How
Correct.
fast are the two people separating after 10 seconds?
Three-dimensional. Normally, you get a 2D where two cars go through a crossing, right? So we are working
Yeah,
2D cases. Now, this is a 3D case. You sit, one person is on the bridge. I mean, the train going, right? And
yeah,
the motorboat is going on the river. So it's a 3D case which you have to solve. So it is a unique question in itself. So that should help you to understand 3D examples on rate of change and see
yeah.
how beautifully this question has been solved in this particular case. Correct? We have
Yes, sir.
multiple choice question. You know, now of course that distance, which is the oblique distance, shortest distance, x squared plus y squared plus z squared, right?
D squared. Yes. Yeah.
FDD. So that kind of makes and then you see the derivative. We have used differentiation with respect to time and implicit differentiation. Y squared derivative is 2y dy dt. X squared derivation is 2x dx dt. And s squared is 2s ds dt. And we have information about these rate of change given in the question itself. You
Yeah.
that in no time we can find the solution of this question. That's the beauty of it. It's a very difficult question.
Yeah.
It can be solved within few minutes. You get the idea.
Yes,
So if
sir.
you understand, it'll be very good for you to do this. Now, next level of question is when we inscribe one shape into the other. So geometrical
Yeah.
create a lot of problems for students I've seen in
Yeah.
papers, and therefore here is one question which is expected to come. Can you please read the question?
Yes, sir. The vertex of a right circular cone and a circular edge of its base lie on the surface of a sphere. The sphere has a radius of 5 centimeters. Find the dimensions of the cone of maximum volume that can be fitted into the sphere.
Right. So what is within what?
So, sir, it says that the right circular cone, sorry, the sphere is within the right circular cone.
Okay. So the vertex of a right circular cone and the circular edge of its base lie on the surface of a sphere. The sphere has a radius of 5 centimeters. Find the dimensions of the cone of maximum volume that can be
Oh, okay.
into the sphere. You see that? You have to
Yeah.
read the statement till the end and makes
Yeah.
absolutely clear that cone is within the sphere. You get the idea? So the
Yes, sir.
tip of the cone and the base of the cone, you can draw it now. You get the idea? So first
Yeah.
thing, you have to sketch and understand, like, what is the situation? What are we trying to figure out? Now, once
Yeah.
that's clear to you, it should not be difficult. Always work with cross section, right? So do not try
Yeah.
to draw a 3D sphere and a 3D cone. Then you'll mess it up. So make a cross section. Cross section of a sphere is a circle, and this cone is a triangle. So basically, you are drawing a circle and a triangle inscribed inside it.
Yeah.
Perfect. Now,
Yes, sir.
how the radius of the two are related. So basic idea is to relate the sphere radius with the cone radius. You get the idea? So
Oh, okay. Yeah.
radius is at the horizontal, right? And
Yeah.
so it could be related with Pythagorean theorem, and some small tweaking of these variables can help you do this question easily. It is interesting question, slightly difficult, but not
Yeah.
very, I should say, manageable. Okay, so that is how you are going to do it, right? So just see how we have related this radius, which is the radius of the sphere, given to you as phi, and
Okay.
the dynamic radius r of the cone, which we need to figure out, right?
Yeah.
And the height of the cone. So height of the cone will definitely include phi, the radius, plus some delta y, correct?
Plus, yeah.
Phi. And that is how you get this equation. You get the idea. Do you understand it from here, right?
Yes, sir. I got it.
Perfect. So very interesting question. Now I think absolutely clear to you. So now let's go and take another question, which is the beam, right? So
Yeah.
read the question, please.
Yes, sir. A wall of a building is to be braced by a beam that must pass over a parallel wall 5 meters high and 2 meters from the building. Find the height of the shortest beam that can be used.
Correct. So this is kind of a barrier, right? And that's
Yeah.
the wall. And 2 meters and 5 meters is given to you. You see there is a triangle here, right? And a
Yeah.
triangle there. These two triangles help you to solve this particular question.
Yes, sir.
And then very important question from test point of view. Every year this question comes. Every year this question comes. And therefore,
Yeah.
this is not to be missed. Is that okay?
Yes, sir.
And okay, so let's see that solution. Okay, so you see similar triangles once again help us. So
Yeah.
from B to C, I'm taking distance as x. X minus 2 is that distance, right? And this is y, and y minus 5 is the above distance. That similar triangle gives you the relation between the required things. Length is sum of these two sides, correct?
Yes, sir.
And then you can easily solve it. It does require a bit of thinking to make this equation. Not
Yeah.
a question, right? This is a difficult question actually. May look simple. So, but I hope you understand the concept.
Yes, sir. I see the concept.
Yeah. So you need to spend some time understanding all these things. Only then you will be in a position to do them. Is it okay? So this
Yes, sir.
continued anyway. So we'll move on to the next set of questions. And this set of questions belongs to rate of change, of course. But we will consider shadow. So
Okay.
when you walk, you have a shadow, right? Now,
Yeah.
that related questions are very interesting. Since what I see is that sometimes we have, for example, in this particular case, well, this is what I wanted to say. This is one of the
Yeah.
most difficult questions on shadow. Please read the question.
Yes, sir. A man 2 meters tall walks along the edge of a straight road 10 meters wide. On the other edge of the road stands a streetlight 8 meters high. If the man walks at 3.5 meters per second, how fast is his shadow lengthening when he is 10 meters from the post directly opposite the light?
Correct. So look here, I've shown from my side a very neat diagram. That is the pavement. You understand these two lines, right?
Yeah,
Person is walking on this side of the road, and on the other side there is a lamp. So if person is here, the shadow will be right there, right? So because
yeah,
it is like as we have seen here. So person is walking in this direction, which is shown as X, but the shadow is in this direction, which is Y.
why? Yeah,
But this distance between the road is 10-meter wide. So now
yeah,
you see the figure, and you can see how you can relate the height of the person, which is 2 meters, with the shadow length S. This is the shadow length at the end.
oh, okay, yeah,
Right? So once you understand this figure, then easily you can solve the question. But getting to this figure itself is a problem when you read the question. You get the idea?
so you can use similar triangles over here too, right?
Yes. And
Yeah,
Pythagorean. So most of these questions are solved using similar triangle and Pythagorean theorem. But the key
yeah,
is sketching correctly so that you know
yeah,
what goes where. Get the idea?
yes, sir.
So let's go through a part of this video. Well, that's almost the solution right there. Uh, I just want to show you the equations. And you see I've written dx, dt, ds, dt, all these things. They are given to us, right?
Yeah,
Rate at which the
yeah, yeah,
person is walking, that rate is dx, dt, right? And then we have
yeah,
written very simple questions, equations with x square, y square, Pythagorean theorem, and got our result, right?
yeah,
So you need to spend some time to understand the logic and then get into these complications, I should say, right?
yeah,
So is this concept clear to you?
yes, sir. It's clear.
Okay. So here is another question. Can you please? So these are simple questions to begin with. So
Yeah,
they involve numbers, not at all a difficult question, right? Half an
yes, sir.
hour video. We have 3 examples in this video as mentioned. Can you please read the question?
Yes, sir. The product of two positive numbers is 288. Minimize the sum of the second number and twice the first number.
So once you read the question, you can form a simple equation and then you can actually get to the solution. Not a difficult question to begin with,
Yeah,
right? So here is another question. Can you please read this question?
yes, sir. A rectangular page will contain 24 square inches of print. The margins at the top and bottom of the page are 1.5 inches wide. The margins on each side are 1 inch wide. What should the dimensions of the paper be to minimize the amount of paper used?
Got it. Now, very interesting question. As you can see, a neat diagram is required to answer
Yeah,
this question. Once the diagram is there, you can relate the area, correct? When we are
yes,
doing
sir.
dimensions, basically we want to minimize the area, correct?
Yeah,
So the margins on each side are 1 inch wide. What should the dimensions of the page be to minimize the amount of paper used? Correct. So
okay, yeah,
the question. So the central area comes out to x plus 3 times y plus 2 with the dimensions given to you, right?
yeah,
And then you will be in a position to answer this question. Okay. Very
yes, sir.
these are common questions in test paper. These 3 questions are always kind of there, right? Some way or the other.
Yeah,
They are simple questions, but they are always there. You should get them so that you are at least 75% above. The questions which I shared with you earlier take you above 90%. That is how the question paper could be designed.
yeah,
Please read this question.
yes, sir. Determine an expression for maximum light through a window which has a rectangular base with semicircle on the top for given pyramid.
Sorry. Straightforward question. We also put this question in the form of a window.
Yeah,
So we have a window which is of this particular shape, and then the light is coming through the window, and we want to maximize the light coming from the window. These windows are
yeah,
Norman windows. So they have a name,
okay,
design Norman window. So if you type Norman window, you get many questions based on it. It is kind of
yeah,
a very popular question which you will see in the test paper. Worth going through it, right? Perimeter,
yeah,
see which sides to be included, which not, right? So
yes, sir.
the center is not to be included when you talk about perimeter. It is that, right?
Yeah,
Until a question is signifying its use also. Is it okay?
yes, sir.
Okay. So let me just select some more. Here is another very interesting question. It is about a ladder taking through the corridor. very important question, which we actually solve using trigonometry also. Since we have not done trigonometry, we have to solve
Yeah.
algebra. So, okay, here are three different questions based on that concept. Okay, can you please read this?
Yes, sir. Question number one. A thin, rigid pole needs to be carried horizontally around a corner joining two corridors, which are 1 meter and 0.8 meters wide. Calculate the length of the longest pole that can be carried around this corner.
Sorry. So you can see two similar triangles are being formed, correct? Length is shown in the red color. So two pieces joined together to give you the
Yeah.
Pythagorean theorem. Perfect. Can you please read the next question?
Yes, sir. Distance between the hockey goal post is 6 feet. If Sidney Crosby is on the goal line, 3 feet outside one of the goal posts, how far should he go out perpendicular to the goal line to maximize the angle in which he can shoot at the goal?
Very important from Canadian point of view. And this question
Yeah.
is so popular that every year it comes. Every year, this question will
Yeah.
come in the test. So these three questions are very important, right? Please read question number three also.
Yes, sir. A tool should.
Right, right. Let's. I think we have the solutions, of course.
Yeah.
Because there the later half is not clear, so I thought I'll show you at the end if we
Yes,
have
sir.
here. Okay, there you go. Okay, so this is like a barrier question which we got last time.
Yes,
Can you
sir.
please read this question?
A
Question number
tool
three.
shed 250 centimeters high and 100 centimeters deep is built against a wall. Calculate the shortest ladder that can reach from the ground over the shed to the wall behind.
Correct. So here we use trigonometry. You could do like we had a similar question earlier, right? We had a
Yeah.
ladder and a barrier here 2 meters away last time, correct? Here we have a
Yes, sir.
small room here, so the ladder will be like this. So in this particular case, I'm using trigonometric identities, basically sine theta and cosine theta, to find the distance. So two different approaches for you. If in case you learn a derivative of sine theta, which is simple, derivative of sine theta is
Yeah.
cosine theta,
Cosine.
derivative of
Yeah.
cos theta is minus sine theta, right? So it
Yes, sir.
actually simplifies the question, solution of this question as compared to the previous one which you saw, right? But they are kind
Yes,
of
sir.
similar questions worth looking into, right? So,
Yeah.
okay. So let me just see some more questions. So as you can see, there are 77 questions in this playlist, means a lot, correct? So it all depends on
Yeah.
how you have to prepare and how much you want to devote on this particular topic. Accordingly, you have good material there to go through, correct? Can you please
Yes,
read?
sir. Ice cream cone is being filled at the rate of 4 centimeter cube per second. The cone has a radius of 2 centimeters and a height of 8 centimeters. Find the rate of change of height when the ice cream cone is half full.
Half full. So we are given the height, right? We're given all the parameters. First thing first, it is
Yeah.
simple. Similar triangle, make a triangle to show you the cone, right? And then relate height and radius as we did earlier also. What will
Yeah.
arise on this side front is definitely one question on this cone and this particular concept will be there.
Yeah.
Now we may ask for, in this case, it is the volume, correct? So
Yeah.
that is how it is. We saw the cone in the sphere also. We saw cone in so many different ways. So cone based question is kind of you say most expected question in your test paper. Okay.
Yeah.
Okay. So many questions are here. Conical flask again, which is again a cone. Just giving you the question, but not getting deeper into this.
Yeah.
Well, there are four questions in this particular case. The last one is a conical reservoir. Do you see that conical reservoir, right?
Yes, sir.
Okay, this I have actually collected all the questions based on cones because cone is a common topic for a test,
Yeah.
right? Therefore, different ways. So, can you please read these questions to understand in what way the cone could be there on the related rate of change?
Yes, sir. So, question number one. The diagram represents an empty vessel in the shape of a right circular cone of semi-vertical angle 45 degrees. Water is poured into the vessel at the rate of 10 centimeter cube per second. Find the rate at which the water level is rising after 5 seconds.
Correct. Second question.
Yes, sir. Water is poured into an inverted right circular cone at the rate of pi meter cube per minute. The height and the diameter of the base of the cone are both 12 meters. How fast is the water level rising when its depth is 2/3 of the height?
Okay. Question 3.
Metal shavings are being emptied into a conical pile whose height is the same as the diameter. If the shavings are spilled onto the pile at the rate of 10 centimeter cubed per second, how fast is the radius of the pile increasing when the height is 5 centimeters?
Correct. So likewise, what I've done here is put all the cone related questions at one place. If you go
Yeah,
through this, you will get an idea that if you get a question related to cone, that is what my strategy could be. That's the whole idea.
yeah,
You find some questions which we have seen earlier in this particular case, correct? So
yes,
that's
sir.
the beauty of this. And with that, I think uh, we can, right. So, okay. So distance and time, this is a very common question, but I'm sharing with you
Yeah.
it is seen in the test papers a lot. So again, please read the question.
A man in a motorboat at A, 40 miles south of bus terminal C, receives a message at noon calling him to point B. A bus making 40 miles per hour leaves point C, bound for point B, at 1 p.m. What must the minimum speed of the boat be to enable the man to catch the bus?
Correct. So slightly tricky question, right? It gives you a lot of information. However, not very difficult if you analyze them because
Yeah.
the 2D question, right? And the Pythagorean theorem can help you solve this particular question. Is that clear to you?
Yes, sir.
Now, the last question which I'm going to share with you is on laying a cable. Most probably, this is the question which you'll definitely get in your test paper. So,
Yeah.
I would like you to actually work on this question. It is every year in one of the test papers. I actually,
Yeah.
my students are in different parts of the city, we happen to see many test papers. Every year, I've
Yeah.
seen. Okay, so read this question.
Yes, sir. A lighthouse L is located on a small island 4 kilometers west of a point A on a straight north-south coastline. A power line is to be laid from L to the nearest source of power at point B on the shoreline, 12 kilometers north of point A. The cost of laying the cable underwater is $6,000 per kilometer, and the cost of laying the cable along the shoreline is $2,000 per kilometer. To minimize the cost, the power line will be built from L underwater to a point C on the shoreline, and then along the shoreline from C to B. Find the location of point C to the nearest meter where the power cable should enter the water.
Sometimes the diagram is given to you. If the diagram
Yeah,
is given to you, it is much simpler. Otherwise, you have to sketch one, right? I
yeah,
actually saw I have very limited space, therefore I did not give the diagram here. How?
yeah,
You have described the situation as it is described in any test paper, right?
yeah.
And then you make a diagram. It's shown right there. You can see that diagram on the right side, right? So
Yes, sir.
diagram, because I'm trying to solve the question in very limited space here. But once you make the diagram, then you will understand easily that how using distance formula you can actually
Okay.
this particular.
Yeah,
Right? So that is how it is going to be. If you go through underwater, then it is a diagonal kind of a thing, and along the
yeah,
shore, which is north south, you're going straight up. Right?
right.
So that is how you make this figure, and the two costs are different. 3 times is the cost underwater as compared to along the shore, and that gives you some complication to it. But it's not a difficult question. It's a very common question seen in the test paper. At least you can save some time if you know the
Yeah,
concept, right? So that
yes, sir.
more difficult questions you can spend more time with and
Yeah,
get your questions very fast, correct?
yes, sir.
So that was the concept. Here, now let's move on to higher order derivatives. So in higher order derivatives, one of the major problem is to find the distance, right? So can you
Yeah,
read the question?
yes, sir. A particle moves along a straight line where displacement x in meters for the first 4 seconds along a straight line is x equals t minus 1 squared plus 4. Find the velocity at t equals 0 and t equals 3, the distance traveled in the first 4 seconds, and the average speed over the interval from 0 to 4, both in.
Correct. So first part is very simple. You have to find the
Yeah,
derivative of the displacement, gives you the velocity, and t0, t3 you can figure out, correct? How will you find the distance traveled in first 4 seconds? Tell me.
yes, sir. So The distance traveled, distance relates to displacement, right, sir? So I think we would be dealing with the initial function given.
Yes.
So distance traveled in the first 4 seconds would be d of 4 minus d of 0, right, sir?
Okay. If you do that, you'll get a wrong answer. We're talking about distance. Think about a particle which moves and then turns back. You get the idea.
Oh, okay. Yeah.
So you have to find the turning points. Within the first 4 seconds, when is the velocity zero? When
0. Oh, okay.
is the sign? So maybe part A is helping you out to figure out, well, it could be 0 and 3. Anyway,
Yeah.
so I'm not giving you any hint, but you have to find the derivative, equate that derivative to 0, and then
Yeah.
find the turning points. So at each turning point, you should find the displacement. Difference of the displacement will tell you the distance traveled during that time. Add them
Okay.
add them up. You get the idea?
Add all
Then
the
you get-
differences, right, sir?
Yes. Then you
Okay.
get the total distance. But if you just substitute 4 here, then you get 4 minus 1, 3, 3 square is 9, 9 plus 4 is 13, which is not the right.
Yeah.
Okay.
Right.
That is the
Yeah.
displacement. Displacement is change in position. Initial minus final. We are talking about
Yeah.
distance traveled in between many times. The person or this particle has moved back and forth. We have to add
Yeah.
those. And when you say average speed, then that distance in part B will be now divided by 4 to get you the average speed. Is it okay?
Yes, sir.
So that's the thing in these questions. Tricky part is to calculate the distance.
Yeah.
Now you can see here, I'll just go to the end to show you. We figure out the velocity. As you can see, we are equating that to 0 to find the turning points. As you see here, turning point is at t equals to 1, right?
Yeah.
And at t equals to, uh, I really don't know what this, because we haven't read this. Okay, so at t equals to 0, the position is 5. You see that it starts at t
Yeah.
equals to 0, which is 0 means 1 plus 4, 5. So it doesn't start with 0, it starts with 5.
Yeah.
You see that? So at 1, it is turning and the distance is 4, but it is towards the south, right? Kind of
Yeah.
but decreases by 1 unit. So all these distances you have to add up, correct? Once you add,
Yes, sir.
then you find the total distance traveled in that particular time. You get the idea?
Yeah.
So make a line graph as shown here to answer your question.
Yes, sir. Sir, so quick
Yes.
clarification. So do we find the difference between 4 and 5 and
Yes.
5 and 13 and then sum those up?
Yes.
Okay. Yeah.
Okay. So I think we could take another question here on displacement time. So you have to focus. Other parts are simple. You have to focus on how do we calculate the distance traveled. Sometimes the question is very tricky. In the second,
Yeah.
what does it mean? Distance traveled in second. Tell me.
In the second second, sir?
Yeah, second. So the first second is from t equals to 0 to 1.
To 1, yeah.
And the second is from t equals to 1 to t equals to 2. So in that duration, what was the distance? Get the idea?
Oh, okay.
Second,
Yeah.
second. So it's a very difficult term to understand, but now you get it, right? Second,
Yeah.
t between t equals to 2 minus t equals to 1, correct?
To 1, yeah. Not 0, right, sir?
No, 0 to 1 is first second. In the
Yeah.
first second, when you start your run, for example, in the
Yeah.
first second, that means from starting to t equals to 1. In the
To t
second
equals
second,
1.
it's
Yeah.
from t equals to 1 to t equals to 2. How much distance did you go? That is what it is, right? So,
Yes, sir.
okay. So in this graph, can you please read this question?
Yes, sir. The graph below shows displacement of a particle moving along a straight line. And at what time is the velocity minimum?
Correct. So from the graph, you have to find the time when the velocity is minimum, right? So minimum velocity, this is, what do you think is the answer?
Sir, we're given a displacement time graph, so I think the answer would be 1 second.
No, this is the minimum distance. When you draw the tangent, this tangent is 0. However, the tangent in the beginning is negative. So wait, that is the minimum velocity.
Oh, okay.
Do you see the trick involved? So
Yeah.
don't just get carried with the graph and understand graph is displacement. We want velocity,
Yeah.
tangent, negative tangent here, 0 and positive. So definitely in the beginning, it is most negative, right?
Okay, yeah, yeah, yeah.
Zero is your answer. Otherwise, you can make a lot of mistakes here. So that reminds
Yeah,
me, another type of question is speeding and slowing down, right? So
yeah.
optimization, let's say speeding and slowing. So when is the object speeding? Tell me,
For this graph, sir?
in general. Okay, let's go to this graph. So
Yeah.
just type in Anil Kumar speeding and slowing. You will see many videos on this topic. Here I just picked up one. Uh, okay, here's the graph. Can you please read the question?
Yes, sir. On the graph are shown the position, velocity, and acceleration functions of an object. The interval during which the object is slowing down is A, B, C, D, or E.
Correct. Now tell me, out of the three graphs, which one represents velocity?
Yes, sir. So I think the parabola represents the velocity, right?
Correct. So in
Yeah.
polynomials, when you take the derivative, then the derivative is 1 degree lower. So the
Right.
displacement is a cubic function here. I've written
Yeah.
very explicitly clear. However, you should understand. One question could be which represents acceleration. You get the idea, right?
Yeah.
So the cubic function here represents the displacement parabola. 1 degree lower represents
Yeah.
velocity, and a straight line represents acceleration.
Acceleration.
Now you can very clearly see which part of the graph for which is positive and negative. Now from the
Yeah.
graph, can you tell me which is the area where the object is speeding? Can you tell me the interval where the object is speeding? Well, the
Yes,
question
sir.
is
So,
interval during which the object is slowing down. Okay, tell me, which is the interval where the object is slowing down?
slowing down is when VFT times AFT is less than 0, right?
Negative. Yes, they are opposite signs. Correct.
Yes, there. Exactly. So if we see when the two rates of change are opposite during that interval, then we can pick that answer, right?
Correct. So looking at parabola and the straight line. Correct.
Yes, sir.
So 0 to 2, you see velocity is positive, but acceleration is negative, right? Opposite sign.
Yeah.
0 to 2, it is decreasing. Correct. Then 2 to 4, both are negative. They are speeding. Between 4 and 6, you notice that parabola is under the curve, but acceleration is above, right? 4 to 6.
Yeah.
4 to 6 also it is slowing down, and therefore option A is the right option. Do you see how we analyze? Correct.
Yes, sir.
But from this graph, I could ask you when the object is moving away, when the object is moving towards, when
Towards,
the
yeah.
object is speeding. All these questions can be answered. So tell me, when is this object moving away from the starting point? Tell me.
Yes, sir. So then we would have to analyze the cubic function, right?
Yes,
The
and the
displacement
parabola. And the parabola. Their
and the
product
parabola.
should be negative for going towards.
Towards, yeah.
And away means both in the same direction. You get the idea.
Okay, yeah. So whenever the rates of change are the same value, then it's going away, right, sir?
Yeah. So product of velocity and displacement will give you uh, approaching or going away parameters. You understand now?
Yeah.
So that is how
Yes, sir.
we have to do this. Extremely important question.
Yeah.
Just so you, if I just do speeding and slowing down, there are so many videos, right? There's so many,
Yes, sir.
so many videos. So you can watch some of them to get the complete concept of all this. Plus, simple graph, right? A very simple video. It
Yeah.
actually helps you to understand when the graph is kind of like this, what is really happening, right? Now, let me
Yeah.
answer one of your very important question. Do you see this concave part?
Yes, sir.
What is written at the bottom? Can you read?
Yes, sir. Moving away at increasing speed and then slowing down.
You understand from the graph? When you are going like a cup up, up,
Yeah.
concave up, and then we have concave down. You understand?
Yeah.
So moving at an increasing speed, you are increasing your speed and then slowing down. Correct?
Yeah.
I'll give you. If you throw a ball, right, you throw with a high velocity, it takes a parabolic path, as shown
Yeah.
the later half of this and the last part. Right? Do you see that?
Yes,
So
sir.
all along in this path, what is happening? Moving away at decreasing speed. You understand? because we have
Okay.
grown with the maximum speed as it goes. At this point, it is minimum zero at when it the peak, and when it turns, it is negative, which is decreasing. You get the idea.
Yeah.
So if you have a concave graph like this, it means moving away and decreasing speed. So these graphs actually give you complete understanding of analyzing a graph. Where is the object speeding? Where is the object slowing down?
Yeah.
What is happening to velocity? What is happening to acceleration? Okay.
Yes,
Now,
sir.
to end this class, let me tell you, if we want to figure out from the graph where is acceleration positive, it will be concave up, and concave down will be negative. Second derivative negative. You understand?
Okay.
Concave down.
Yeah.
So that winds up all these things because here it was analyzing most velocity and things. But this is a very
Yeah.
important video, right? You need to look into this. So I hope with this you understand the concepts. So let me give you the calculation of this was not the list. Okay. Um, which was that file? 77 videos.
Oh, sir, I think the 77 one was up there.
Yeah, at 73 it was. Let me just see. So anyway, you know how to search, right?
Yeah, yeah.
Sorry. This is yeah, it was slightly above it. Right? This one, 77. Yeah. So let me just share this on the playlist.
Yes, sir.
Okay, so I'm stop sharing this. So we'll end the class at this moment. So that's the link.
Yeah.
Okay, Akshay, can you revise or summarize what did you learn today?
Yes, sir. So today we touched upon the optimization problems, and some of the problems they were a sharp contrast to what were in the Nelson book, because in the Nelson book they were just like fencing problems and just very few time problems, right? But with the videos, I think I got introduced to a lot of cone problems mainly, because in particular, my teacher said that there would be a lot of cone problems. And on top of that, I also saw how implicit differentiation can be used in relation to these optimization problems, and also the velocity, acceleration, and displacement graphs. I think now I know that with the concave up and concave down, I can analyze the graph much more easily.
Correct.
And I think all the concepts that were learned before, I can tie it in now and then find the answer much more quicker.
Sure. All the best, Akshay, and keep performing as you've been. Looking forward for another 100% from you. Great.
Thank you, sir.
Have a great day. All the best.
Thank you, sir. Bye.